Hello, everyone. Welcome back to the first video of semester 2. We're going to kind of just pick up where we left off. So talking about lesson 17.2 and the fundamental theorem of algebra. I do have a note sheet posted for you guys on Google Classroom, and then a pen or a pencil and a calculator is what you will need for today. Okay, so this actually should be somewhat familiar from what we did in Unit 2 when we kind of worked backwards. So remember, if we are given the solutions, x equals 2 and x equals -5, we can work backwards to write those as factors, and then work backwards again to multiply them and write it as a quadratic. Well, the same thing goes for polynomials. We may just have some more solutions or zeros or x-intercepts. Remember that all of those mean the same thing, okay? So in example B, it tells you that it is a third degree polynomial, which remember means your answer should look like an x cubed polynomial. That's the degree. And then they give you the zeros, so at 0, 2, and -3. So remember that can be written as x equals 0, x equals 2, and x equals -3. I'm just going to write these here. Okay, so what happens is in the first step, when you write them as factors, you either add or subtract that number over. So you do the opposite operation. So with 0, it doesn't really matter. You can just write it as x. With 2, you're going to subtract it over and write it as x minus 2. And then with -3, you're going to add it over and write it as x plus 3. Okay. Then what they did here is they went ahead and multiplied these two here by using FOIL or box method, and they got x squared plus x minus 6. And then they brought down the x, and then they just distributed that x in. Whoops. And they got x cubed plus x squared minus 6x as their final solution. Okay. So we're going to do a couple examples like that, and we'll do a couple that have maybe 4 terms, and then we'll also do some that have imaginary terms. Okay, so let's try one here. So first of all, it says n equals 3. So that part right there is telling us that it's a third degree polynomial, so we should end up with an x cubed as our highest degree, right? Or our highest exponent. Then it tells us we have x equals 0, x equals 5, and x equals -7. So when we write them as factors, we're going to write them as x. Remember, if it's 0, you can just write it as x, or you could write it as x minus 0 or x plus 0, but that doesn't really change anything. Then we have a positive 5 here, so when we write it as a factor, remember we're really just using the opposite sign. So x minus 5. And then we have -7, so we're going to use the opposite sign and write it as x plus 7. Okay. You have kind of 2 options here. You could either distribute the x to either the x minus 5 or the x plus 7 first. It really doesn't matter as long as by the end of it you multiply all 3 of these terms together. I personally would probably start out here and multiply these. So I'm going to use FOIL for this first one. X times x is x squared. X times 7 is 7x. -5 times x is -5x. And -5 times 7 is -35. I combine like terms in the middle there. And so I get x squared plus 2x, because 7x minus 5x, and then minus 35. Then just don't forget to bring down this x. And so again, we would distribute that in. And so your final answer would look like x cubed, plus 2x squared minus 35x. So you just add a little x to all of those. And again, you could write it as f of x, g of x, whatever you want, y equals, but now we have our polynomial. And that's it. Okay. So I want you guys to go ahead and try this next one. So you're going to pause the video. So part B says n equals 4. So your final answer should look like a 4th degree. And then the zeros are +1, -1, +5, -5. Okay, so try that out. Okay, hopefully you paused the video and I'm going to walk you through the work here. So first of all, zeros at positive 1 and negative 1 mean it should look like x minus 1 and x plus 1, right? And zeros at positive 5 and negative 5 should look like factors of x minus 5, x plus 5. So in blue, I went ahead and multiplied the first two, x minus 1 times x plus 1, and I got x squared minus 1 when I simplified. Then in green, I went ahead and multiplied x minus 5 times x plus 5, and when I simplified, I got x squared minus 25. Okay, so I factored both of those, but then those also needed to be multiplied. So in my final step, I took x squared minus 1 and multiplied it by x squared minus 25. And for that, I used box method. You could use either FOIL or box method for all of these so far. And so I ended up getting x to the fourth power minus 26x squared plus 25 when I multiplied those. Okay. Awesome. If you want some extra practice, you can go ahead and try this one here. Okay, it's a third degree with zeros at 2, -4, and 1. All right. Then let's go ahead and keep moving. So remember we talked about complex conjugates. So it says here, the complex conjugate root theorem states that if a plus bi, when b does not equal 0, is a zero of the polynomial function with real coefficients, then the conjugate, which would be a minus bi, right? Remember that's what a conjugate is also a 0. Or a solution, or an x-intercept, remember those, or a root, remember those all mean the same thing, okay? So then example C, it says find a third degree, okay? So again, it should look like x cubed when you're done, but this time it said it only has the zeros 3 and 4i. So what this means up here is that if it's positive 4i, it also has to be negative 4i, because remember that plus or minus sign always comes with those imaginary terms. So that's what they did here. They wrote it as x equals 3, x equals 4i, and x equals negative 4i, the complex conjugate. Then again, they wrote them as factors here. What you're going to want to do is definitely multiply the terms with the i's first. So you're going to want to multiply those conjugates together, because that's the nice part, is it will get rid of the I, okay, or the imaginary. And then they just multiplied these together for a final answer of x cubed minus 3x squared plus 16x minus 48. And they had that third degree polynomial just like we said. Okay. So let's go ahead and try a couple. So you have n equals 3. Remember, that is not a solution. That is what the degree is. Okay, so maybe jot yourself a little note that that is the degree. Then you have the first solution is x equals -3. The second solution is x equals I, but do not forget here that the third solution is x equals -I. Remember, they go together. Whenever you see a positive imaginary, you have to have its conjugate, the negative imaginary, and vice versa. Okay? So when we go ahead and write these, x equals -3 is going to become x plus 3. X equals I is going to become x minus I. So we would subtract it over. And x equals -I would become x plus I. Okay, so again, I'm going to start by multiplying these together. So x times x, x squared, x times I, ix, or xi, however you want to write it. Just keep it consistent. -I times x, -ix. And then -I times I is a -I squared. Okay, so these are going to cancel. And then remember, I squared always gets replaced with -1. Okay, that's from unit 2 as well. So we're going to replace that. And that would have been a -I squared. So -1, which is going to be +1. Okay. So now we're going to go ahead and we need to bring this down still. So we're going to do x plus 3 times x squared plus 1. And again, you can do box method if you prefer, or you can FOIL if you prefer. And I'm going to do x plus 3 and x squared, plus 1. So x squared times x is x cubed. X squared times 3 is 3x squared. X times 1 is 1x, and 3 times 1 is 3. So then we would write our final answer as x cubed plus 3x squared plus x plus 3. Okay. And notice nothing really combined there, but that would be your final answer. And we got a third degree polynomial, just like it said we should. Okay. All right, so if you guys wanted some extra practice on this one, you could go ahead and try part B. Okay, so you've got x equals -2, and you should have x equals -3i, or sorry, x equals 3i, but you need to add in x equals -3i. Okay, so get some practice with your multiplying there. And then this next one I want to talk about really quickly. So it says n equals 4. So that's a little different than what we've seen because that's going to be a fourth degree. Then it gives you x equals 2, x equals -5, and it says x equals -4 is a double root. Remember, we talked a little bit about double roots last week or 2 weeks ago. And a double root is when it touches and bounces off the x-axis, okay? So that's going to count as 2. So whenever you see that word double root, you're going to want to write x equals -4 and x equals -4 again, okay? So I'm going to go ahead and clear this out of the way, and you'll see that that's exactly what I did. So here I wrote it as x minus 2 and x plus 5 to account for these. And then this x equals -4, that's a double root. I wrote it as x plus 4, x plus 4. So then over here, I multiplied those, x minus 2 and x plus 5, and I got x squared plus 3x minus 10. And then here, I multiplied the x plus 4 and the x plus 4. And I got x squared plus 8x plus 16. And then you have to multiply these together, okay? So then that's what I did here using the box method. And I combined like terms to get x to the 4th minus 5x cubed plus 30x squared minus 32x minus 160. Okay, so basically, as long as you know how to multiply polynomials using either your FOIL method or your box method, you should be good to go. And as long as you know that you're, when you multiply I and when you have I squared, you get a -1, or you plug in a -1, okay? So here's another example of that if you guys wanted to try this one. It's a third degree, so n equals 3, and you have x equals 1 and x equals -5i. But remember, when you have -5i, you also have +5i. So in blue, I multiplied those together first. I remembered to plug in a -1 for I squared, and I got x squared plus 25. And then I had to multiply that by the x minus 1, and I got x cubed minus x squared plus 25x minus 25. Okay. So here are quite a few examples. We will do some more in class. So if you have any questions, let me know. Have a good one. Bye-bye.